Welcome to another Confluence podcast. I'm Randall Stevens. I've got Evan Troxel co-hosting with me today, and special guest is John Cerone from SHoP Architects. So thanks for joining us, John.
Thanks for having me.
So I'll give a brief intro from my perspective, and then I'll let you kind of give a little more color and flavor to who you are and what you do. But I got to know John obviously through his work at SHoP, but it started with a couple of colleagues of his, Jeff Bell, who was Jeffrey Bell's was a UK architecture grad. I always like to brag on the good UK architecture grads who go on to do great things, and Jeff is one of those. But Jeff Bell and Adam Chernick, who is at Amazon now, has left. But those guys were always involved and had participated in several of the Confluence events. And then when I'd been up to the office and John and I had met, but then when we did our one-day Confluence event in Brooklyn this past year, John participated, and then we invited him to come and speak in September when we had our event here in Lexington. So it was great to have you join us for that, John, and enjoyed the conversation. But official titles: you're a principal at SHoP, you're the director of design, visualization, all the construction. I'm sure that's what we're going to dive into is kind of what you got to do, but maybe you can give a little more official about what you do there at SHoP.
Sure. Yes. And again, thanks for having me and allowing me to participate in all this. We have actually a few great UK grads. Who Scott Overall is here and leads a lot of our computational efforts on some design and manufacturing. So, keep them coming.
Yeah.
I'm John Cerone. I'm a principal here at SHoP Architects. I've been with the firm since 2008, after I had graduated from grad school here, and previously had been the director of virtual design and construction, which we can get into all the kind of jargons between BIM and VDC. And I think I've made comments on other, interviews or presentations around our avoidance, or we try to avoid jargon. And so things like building information modeling is BIM, and virtual design and construction, they sort of inevitably become these acronyms. But really, I lead the efforts towards model-based technology here at SHoP. Initially, really understanding how we can leverage the models that we create, the three-dimensional digital models. That's the medium that we work in. How you can, of course, use them to design the sort of three-dimensional composition, describe the project, how that works in a design process, how you iterate. Of course, they're great for rendering, they're great for visualization, but my focus from the beginning had really been with a lens around how to make those models actionable, how to enhance parts of those models to communicate with contractors, to facilitate the execution of the project. So it's really, and there's a lot of different technology, obviously. Models come in different forms. There's a lot of software that manage different types of three-dimensional data and tabular data. And all, there's a deep stack of tools that SHoP leverages to design and execute those projects. And so it's a long-winded way of saying, I'm here to help us use 3D models to design and execute projects better, leverage technology for that. But that's really the DNA of SHoP, and what attracted me here in the first place. So using technology and models to do stuff.
From my time being around you and listening to you present, it's and correct me if I'm wrong, but the general idea is that you should be able to fabricate and make directly from without having to translate this into some interim form like 2D drawings. If you can get the data accurately in the computer in such a form that you can get that translated out for fabrication of pieces and parts, and then ultimately helping for complex projects, assembly on the ground, and the teams that are actually going to put these buildings together. Is that fair?
Yeah, I think we try to avoid abstraction as much as possible. So you use the energy, which doesn't mean you model things unnecessarily to certain details. Obviously, there's a huge role of automation involved. But yeah, I deeply believe that the 3D model can be used to coordinate, to manage the logistics, the complexities of a project, but we can design and use the byproduct of our design, enhance that for fabrication. So communication to machines or people. There's just a huge, opportunity to streamline the way that we approach describing and then delivering projects. Our industry in general, that contractually our deliverables are still 2D documentation, and I believe that will shift. Particularly, and we'll get into this, the more industrialized our industry becomes, the more we're left. The CAD CAM revolution, hit aerospace, automotive in the 90s, and I think advanced manufacturing has afforded a lot from those advanced processes of G code, taking three-dimensional elements and having the precision of machining, creating code that drives those machines. That was the early stages, that unlocked a huge amount of opportunity of precision, of, managing tolerance, managing complexity, managing variation of piece, part, the component. And that will inevitably happen in our industry. We're going to start manufacturing parts of our building. I mean, we already do, but we're going to start manufacturing larger and larger parts of our building and bringing more things from a factory on site that will constitute the building. So we will assemble buildings in the future. I believe that.
I have a question for you, like a philosophical question for you here, John, because what you say sounds totally practical. I mean, a lot of people are talking about this too, and you're not just talking about parts, you're talking about giant assemblies and panel systems and all this stuff, right? And then there's like the side of this that is the AHJ side of things, like the permitting process, the review. And so like a lot of the reason why it's still 2D is because of that, not because of the construction of that stuff. What do you think is going to drive this change? Is it just you and the Skunk Works and like actually going and really, really pushing on this, and it's going to pull the jurisdictions along? Or do you think this is like a two-pronged or a multi-pronged battle with contracts and AHJs and insurance and builders, right? Like there's an intertangled total mess here, right?
It's huge.
And so
it's huge.
I'm just wondering if you see kind of where the pressure's being applied to get the fastest result to really realize this kind of practical vision that you have.
Yeah. No, I mean, it's an enormous, multi-pronged, incredibly deep amount of stakeholders. And there's a huge amount of inertia in the industry. I mean, there's a resistance. We're trying to steer a very large ship that's been moving in one direction a long time. It's going to come through. That answer is multifold. I think it's going to come through really great collaborations. I think one thing to point out, which I think is going to be irrefutable in the near future, it's not a technology problem. We have the tools, we have the software to simulate all components of our design, to fabricate at the highest level. I mean, you see what's happening in aerospace, it's not a technology problem. We can design complexity. We can manufacture, fabricate. It is obviously a behavioral issue. It's the accepting new methods, proving that new methods have the fidelity, they're safe, that we're not taking enormous risks by changing the mode of communication. I don't think no one is interested in skipping any parts of what, like, the jurisdictions, we have to comply with standards. We have to comply with codes. And I don't think there's any appetite to short circuit that. But I think going back to certain first principles, understanding why codes are set up how they are, the ability now to computationally simulate the real performance of systems, unlocks potentially new ways of approval, performance-based approvals versus, prescriptive rules. I think one thing that's happening is, younger force, and I know this almost sounds cliche, and because I played a lot of video games growing up. My third grader plays a lot of video games growing up, and just the spatial awareness, I think a younger group of people that are moving up through, will be in the authorities' offices and will be in the workforce, this sort of gamification, there's a accessibility to three-dimensional information that's becoming more accessible or more prevalent. It's interesting. We're trained up on all the tools. So, in our design stack, we use Rhino 3D, obviously Revit for documentation. We use the Dassault Systems suite, CATIA for modeling, manufacturing, and, engineers, SolidWorks, Inventor, all these tools that you're trained to do, you learn in your university and in practice. Stakeholders, clients, a lot of people we collaborate with weren't trained up in these 3D tools. And they shouldn't be. They shouldn't have to be. They're not intuitive. They're good at some things, not great at other things. And I think we're seeing a whole ecosystem of people developing, web-based tools to lay out your house. Small, games on mobile devices. More agnostic platforms for viewing 3D. Before can send GLBs to people, like file formats where your phone can now open native 3D models and spin them around. I think some of this is a response to just the, games have moved to full, very three-dimensionally and material-rich environments. And, people moving up in that, it's becoming more accessible. It is interesting because sci-fi, I feel like, always leads a certain direction. Like, they get a lot of things right. And you even think back to the old movies where someone's, going to break into the Mission Impossible, or the Impossible Mission, I don't know, copyright things, but like, you've got to go in and do the thing. And they've got those, and first it was wireframe, Tron's 3D, but like you get the map and the schematics in 3D, and it pinpoints where, like, I don't think that that's wrong. I think that was obviously a graphic and a demonstration in a sort of idealized UI. But the reality is people understand 3D like that. That's legible. I don't think clients, and often even in schools now, people aren't really trained or are really not learning how to read plans. I mean, I think you understand it from a layout perspective, but plan, section, elevation aren't really the most intuitive way to understand a space. And it is still, we live in a 3D, existence. And I think it's just more accessible. And so when things are easy to navigate and it's more intuitive to understand or to interface with 3 dimensions, the more people that will be the expectation. And I think it's a long-winded way of getting to the point where I think that the 3D and our ability to process and review in 3D and make comments, I think we can get into some of this. Like, VR is virtual reality is still a little slow, I think, for adoption. There was a big burst that we thought, during the pandemic, that would be everyone would have the headsets on and access it. So there's still nuances in hardware and what people will accept to engage 3-dimensional environments. But I think what we're seeing is if you can provide really simple, intuitive, immediate access and clear navigation to it, people respond really well to being in 3D, to commenting in 3D. And we're seeing, review platforms where you can review. We're working with several in the office and creating our own where you can review projects in progress, the commentary. You're essentially setting up an environment, a persistent 3D environment. That is the project. So it evolves, options are discussed, constraints are diagrammed, decisions are made, results are represented in 3 dimensions. And the more that happens, the more I think we get used to that way of working. Decisions are made very quickly. You have confidence in the making that decision in the context. When you're looking at a detail or understanding aspect of the design, seeing the surrounding context is very helpful. And so decisions are made faster, and there's no reason that, especially when we overlay performance data on those models, when you can review the discussion around systems in that building, when you can see the analysis of egress and environmental performance overlaid on that 3D model, that there's no reason we can't also digitally stamp or approve it in that same environment. So I don't think, it's going to take a lot of work. It's going to take prototype projects. It's going to take great collaborations with designers, innovative contractors to deliver these buildings. But I think when we see these ways of working actually working well, we start to see construction schedules becoming expedited. When we see, I think margins increasing, it will be sort of irrefutable, and it's hard to not get on board with the way that we approve buildings. I think it has to happen.
And you made a comment, I can't remember if it's when we were in Brooklyn or here in Lexington, but if I remember right, you were saying the designer should just have to describe the surfaces, right? That design should be that simple. Describe the surfaces that you want, no matter what the complexity of those shapes become. And then as a secondary kind of process, and the complexity of how that gets made, how it should be formed, is a second. So everything that you were just describing sounded more about like the communication process of deciding what a lot of those forms should be and what's going to work in a specific project, as opposed to constructability, which I kind of framed, at the first part of the conversation. But it seems like there's really 2 benefits of this kind of a workflow. It's both communication in the design process, and then ultimately fabrication or making from that info and data.
I mean, that's a great point. I think it's the synthesis of these. So it's not mutually exclusive. I don't want to marginalize design at all. I mean, we believe that great design is really important. We believe that there's a benefit to great environments, like at an urban level, and how it affects the quality of life. Is a deep, fundamental element at SHoP. I think the issue that we have in an industry is that design, unfortunately, is a very, why the building is what it is and why it is a very small percentage of the design of the life cycle of a building. So, it's that small percent, and a lot of the effort goes towards the coordination, documenting how it will be done. So what we're hoping, or what I would imagine, happening is if we can start to automate or in real time evaluate how it's done, understand the constraints, understand the systems that fulfill performance requirement, we can shorten the effort needed to abstract the design, to document it, to explain it, sort of inefficiently, to produce it. And so what I think what you were talking about, Randall, the idea of this wireframe, if we can describe, because again, not trivializing, I think we don't want to be stylists. It's not about a look. And in a lot of ways, SHoP, we don't have a kind of signature formal move or material move that we make all the time. Like, you can't there's no tell. Like you can't just look and say, oh, that's a shop building. And we pride ourselves in that because every project is different, and we kind of work from the programmatic requirements, the performance requirements of the building. And of course, there's context that we want to fit in. There's history that we want to fit in. There's materials that work well in context and with what certain clients are trying to achieve. So the composition and material application is the core of what we do, but in service of a great environment. Issue in our industry is, one, it takes a lot of effort to model those and produce imagery of those. And then once that's approved, this is what it's going to be, then you get to the business of working with contractors and subcontractors to start understanding how you would actually do it and what it will actually cost. And that serial process, that's not sustainable. And so the approach that we have sort of defined in SHoP and believe is scalable is this concept of wireframe modeling, lightweight datums, lightweight geometry, and try to describe the composition is lightest weight inputs as possible that remain flexible, agile, and in that environment, invite people, and it's contractors, subs, manufacturers. It could be industry adjacent manufacturers. Invite them in to look at those surfaces. Treat that wireframe more as a 3D marketplace. I don't want to get too far into that, but the idea that you can look at, this is what we're trying to achieve. This is our design intent, and allow them to host systems on those wireframes. And then with that, you'll get, we can continue to adjust dimensional, we can continue to adjust the design. Those systems should be able to update. And I understand that's not commonplace right now, this idea of modeling fully flexible fabrication systems. Again, that's not a technology constraint. That's a sidebar. That's just not the way we work. But the more we're able to apply higher fidelity systems models on top of design models, the more accurate quantity takeoffs, the more accurate performance simulations we'll get. So we should be able to have full creativity in design and in real time understand the implications of the things we're proposing. So we want a curved surface of a certain stone because that look feel. We should know in real time what vendors can provide that stone, where it comes from, how it was sourced. I think when we start getting, and this is a sort of asterisk, but this is the more industrialized and precise we become, which is what these model-based processes allow, the more availability we have on the implications of that. So where materials source, obviously the carbon impact or environmental impacts, but also labor impacts is something that, the traditional design and source, execution process is really far removed from ethical sourcing. I think to that point, actually, Evan, I think some of the forcing factors are the responsibility of the industry to perform better, both from an environmental, but also from a labor standpoint, will force us to work in new ways to be more precise in designs. Sorry, that sort of goes off on a tangent, but we shouldn't have to model so much. I don't think the future of our industry is architects making fabrication information. I think it's us working together with makers and engineers to look at that same environment. This is our intention model, and this is what systems allow those vendors or those stakeholders to host their systems on top of that, so we can all look and make, approve those or make adjustments from a cost, a time, or a performance standpoint.
There's so many delivery models. Well, not so many, but there are other delivery models that maybe don't allow for this as well, like design, bid, build. But then also there's the like the tech savviness or just the savviness of the contractor. And like they have this alignment with jurisdictions to say like, well, we need 2D plans. Well, so do we, right? And those feed each other. But what you're talking about is you're talking about a different breed of contractor and even owner and vendors and like all of these. You've created this new ecosystem where everybody sees the value in these lightweight models and flexibility, being able to make design decisions as early as possible and still maintaining flexibility throughout and delivering something more precise, probably faster, with all of these environmental boxes checked as well, and the labor, the ethical sourcing and all of those boxes checked as well. And so like you're building this tremendously valuable ecosystem that to me, it's like it all has to change all at once, right? It's everything everywhere all at once, kind of like that idea, right? And there's so many people who are still relying on these old ways, but it really does kind of take a lot of like examples to say like, okay, now everybody else has permission to do this too, and for all of these reasons, because they all line up. And man, this is just there's a lot of territory to cover there for our industry to get there. But it's great to hear, and thank you for actually just like really taking the time to go through so much of that, because what I hope to do with what you just said is just give people in the design part of that equation and whoever else decides to listen where to apply the pressure. Where are the fulcrum points in that equation to apply the most leverage so that can happen sooner? Because I think everybody who's listening to this is very interested in that happening. And at the same time, a lot of people are like, I don't know what to do about it, so I'm just going to stand back and watch.
Well,
right? Because
I was just going to say, I think I heard you comment, John, that we can talk about some of the specific projects that you all have kind of implemented these kind of practices on. But, once a contractor has had the experience, it's like they don't want to go back. It's like, okay, that's a much better way of, working and communicating.
And there are contractors, I think that realize that understand the industrialization, are embracing it, certainly want to drive it. We're in conversations with several around these, we're very open source or an open book about our, because I think some of the challenges are there's a perspective that we have now just by certain projects and the way that we work that you can't unlearn that. So I think just from a very technical standpoint, this idea of what software lets you, draw a line and create surfaces and then take that surface and thicken it to a certain, dimension of steel or aluminum. And then I want to what allows you to be that precise and, hold that kind of information. That off of that, we need to divide, a backing strut by a certain amount because that's engineering performance and like host all these multi-material systems. There's just, I don't think people have worked that way a lot. And we certainly to execute certain facades on our projects we've done had gotten that experience. And it really is just this crash course in what tools work well. That's a little bit of a ramble. I mean, I would just say, if I were rephrasing all this, like I don't think the availability of some of these tools or a certain way of working has been widely taught or experienced in our industry. So some of this is just a case of genuinely not knowing. I mean, everyone, our design tools that are people understand commonplace. There's AutoCAD in 2D, there's Rhino in 3D, there's SketchUp in 3D. And those are the tools sort of people think of like Rhino and SketchUp as creative design tools. You've got 3D Max and Maya. I don't know if that's still being taught in school as a viable, authorship tool. I think there are ways absolutely of using those as authorship tools. But in general, you're kind of a Rhino. If you're a 3D company, you're a Rhino or
Form Z.
SketchUp.
You got to give Form Z.
Oh my God, Form Z. I learned that was my first taste of 3D. Actually, that was the thing in undergrad. I had an unbelievable professor. I went to undergrad at Miami University in Ohio. Form Z was
That whole team's
product
in Columbus.
out of Ohio State.
Yeah.
And I had this unbelievable professor, Raleigh, and it was an elective class, and I just didn't, we had Maylines. We were doing the drawing, on Mylar and all that stuff. And I just remember taking an elective on Form Z, and it just an incredible educational tool, a modeling tool, drafting tool, but just this idea that this can be the project, and I can resolve details. I can visualize it. I can create renderings to show people. I can create the plans or sections. That idea that that to me was more of a sort of philosophical shift and a lens that now what are the best tools to do that? So it's not sort of fetishizing any certain tool, but it lets you gauge whether this tool is moving in the right direction. Is it performing the way you want? And I think just the pursuit of finding the right software or the right combination of softwares to operate a certain way that is a very sort of effective sort of 3D stack has it's understanding how it should work and then finding the right tools that either perform or don't. And I don't think we are challenging that enough now. I mean, I think eventually there's more and more of a thought like this is going to end up in Revit. Like the documentation is in Revit. If you need to do a huge drawing set out of a 3D model, there's no tool that produces that better than Revit. So that's become obviously the industry standard. That is sort of synonymous with BIM, but Revit doesn't have a connection with that kind of what you're doing in Rhino or SketchUp, which is authoring geometry. These are geometric modelers, and then systems need to be applied to those. So, we found our kind of good solution or that works for us in this hybrid Rhino for fast design authorship and then leveraging CATIA for deep systems modeling. And I think Grasshopper, parametric modeling is certainly that's not new to the scene now. And I think a lot of people are doing incredible things with it where you can build really complex fabrication or fabricatable systems in Rhino. That idea of creating surfaces or guiding geometry that then is enhanced by systems that you define. We do a lot of that work too in Grasshopper, but there's just a sort of scale where if you really want to sort of leverage parametric fabrication systems, like there's a phase shift when you move to something like that can manage all of the lightweight geometry and the deep systems modeling. So I say all that just because we have, by some of the projects, we engaged other ways of working in those other tools, more like aerospace, automotive tools, and understood how accessible manufacturing information is on top of lightweight authorship data. So we have that perspective, and I think that the more people understand that, again, this is a very roundabout way of getting it, but we are talking to and in conversations and potential collaborations with contractors that really understand it. They are doing not the same building every time, but they're using systems. They need to be in control. They want to templatize how systems operate. So it's a panelized stud frame that's got layers of chip, and there are rules of how those overlap. Tools that can catalog that and really allow them to move quickly from design input that they don't necessarily trust, it's sort of abstract design input, to turn that into manufacturing information, bills of materials, logistic sequences, that we're seeing the appetite for that from some innovative contractors now, and doing projects with people that agree with a way of working. And I think design build is fantastic for this. I think you could do it in other models, design bid build. I think it's more of it's people, it's who you're working with. It's a aspiration and an appetite to innovate, to find better ways. And to your point, Evan, it is an enormous thing. And I think it is everywhere, everything, everywhere, all at once, but it's going to be incremental. So it's the understanding of how the big philosophical shift and then proving it out through, we're going to do it on this scope, and these are the sort of KPIs that we're going to achieve, and these are the inefficient elements that we're going to cut out by doing this. So that's a whole other exercise, defining prototypes that give the whole team assurance that we can automate this and that we can short circuit a huge amount of inefficient deliverables into sort of the design model to the manufacturer. So it will happen through case studies.
John, I know, as you all began kind of developing these ways of working, I think you said you all worked on, smaller scale, some pavilions, some projects where it lets you kind of test some of these ideas. And then ultimately the Barclays project, I think, was your all's, like, okay, this is scale, even maybe wouldn't have happened without, using some of these kinds of methods. Maybe we can kind of turn this part of the conversation to, what does that go back 15 years now? What's Barclays?
Yeah, 2009 to 2012.
Yeah. So what I'd like to understand is you're using some off the shelf tools. When did you discover CATIA versus some of these other tools? And then, 15 and 20 years ago, how much code were you all having to write yourself versus, has that matured? Where are you all doing your own, development? Because I've seen some of you all are actively building some of your own tools for doing some of this versus what's commercially available.
I mean, it's an interesting case. So 2009 is when Barclays started, and we won't get into the whole sort of origin of why it came to our office. But, that's actually right when Grasshopper was entering as the parametric modeler. Grasshopper kind of killed generative components. But, at that time, it was quick, it was accessible, and I think you could do a lot with it. It wasn't as mature of an ecosystem. And right now, if you fast forward, a lot of the more sophisticated things we're doing in Grasshopper is there's a lot of code in it. So a lot of those nodes, there's Python and sort of C# code embedded in it.
And I would assume that through the education system, you're seeing a lot more students come out knowing, how to use those tools.
And it's I think we received the benefit of the core DNA and the thesis, the philosophy of the firm certainly attracts certain tech minds,
sure,
but it also attracts, I think designers that care about material. And
sure.
So we can mix our teams up so that we have a nice balance of computation and design. Not that they're mutually exclusive, but typically, I think people's interests. So we can blend those well. But so 2009, Grasshopper was there. Our initial design studies are really coming through just kind of splines and traces in space in Rhino. So we knew the project was going to be set up in Rhino. It wasn't design build. So we had a very specific deadline in terms of opening day. It had to open for the Jay-Z concerts. So there was like a very specific day that it had to open. There was a budget. We were basically given a sort of premium. You can hit, this amount to enhance the look of the project. But it's a constraint. And of course, we already had the site constraints of, there's no laydown area. It's downtown Brooklyn. It's over all the subway lines. So it's a complex site, and we had very strict constraints. And the toughest one of those constraints is at 3 years. So a project to be, sort of begin concept and move through in 3 years, that's a challenge. And it's interesting. So we were working in Rhino, and we were smart in, rigging up the design models we were doing, using Grasshopper to output, quantities in real time. So we tend to iterate a lot. So we, define the project into certain regions, and then we're pushing and pulling, whether it's an aesthetic reason or sort of a sightline performance reason, getting the real time metrics. This is happening within the first week of concept. And again, my lens is on to modeling for manufacturing. My Seek partner, Adam Modisett, who's now teaching at MIT, he had done his architectural thesis in CATIA. So this sort of rogue In terms of parametric modeling, he was guiding that I should just add that Rhino and CATIA play geometrically, they play really well together. So you could take those curves that we were defining in Rhino, and work on them in CATIA in terms of the more parametric automation. So it's, at the time, it was something we were kind of balancing. Like you could do that in Rhino, even in a sort of immature ecosystem of Rhino, but we knew that this would have to be manufactured and decisions would have to be made well. So we committed to the robust, automotive. Obviously Frank Gehry sort of famously applied it to architecture, but we were using it in a slightly different way, or we didn't go set out to do that, but we ended up using it in a slightly different way, and that it was just direct communication with manufacturers. So I drifted off. How much of this did we do? So that we're using CATIA. So just the choice of using that was different. We got very good at leveraging the systems that are native in that tool, which the big concept are engineering templates. They called them document templates at the time. Engineering, this idea that you can model this huge amount of relationships, how this grid, the grid on the ground, it gets these curves in space, forms points. Those points, it's all of the things that were in generative components that are in Grasshopper. There's relationships of adding on features to basically a history stack, but with a lot of control. So offsetting of very specific amount, or I should say, very specific parameter that you can always change. And then once that's offset, this. I want a member to be this deep, and then adding bolt holes, but the hole is this big or the bolt is this big. So we need that plus tolerance. So we were wiggling the design from a surface level, which became panelized. And that is all, Adam, it was really a crash course. He taught me CATIA sort of in real time. And he was running the parametric rules, which is basically EKL. That's CATIA's scripting language. It's VB. It's based on VB. And so that is all custom. So there's no, it doesn't come with walls. It doesn't come with specific features or buttons that are for architecture. You're defining it. This is the steel profile they're going to use. So that's what is, extruded over these things. And that's all scripted. It's like scripting language. So the automation comes through a logic and a scripting that we were defining. Adam was writing on the design side, and I was creating templates of these, mega panels with the manufacturing tolerances, the sheet metal, bending, K factors, all the kind of physical systems. But we sat next to each other physically, but we would also sort of share a Google Doc of rules. Like, these are the parameters, and we created a joint table of logic that his design model would call my engineering templates, and it was a way that we could, in real time, we were sort of doing what I had just described, probably too verbosely before, of like, we were doing everything all at once. It was like talking with the suppliers, we're understanding the physical constraints of their systems, we're building out, working with engineers and the manufacturers, taking into account all of their constraints and building that into a template that the design model could call. So that way of working, we can't unknow that it works. And but you didn't set out to do that.
We didn't set out to do it either, which is kind of crazy, because Randall's question is like, looking back, like where were you? You're kind of in the same, like, you still have this way of doing things. You still write a lot of scripting and code. You're even writing your own apps. You're doing all these things, but like, you didn't set out to become this. Like, you were that, and you have iterated and iterated and iterated and just kind of grown through that process over the last 15, 20 years. We were trying to, that project, we were trying to solve problems as fast as we possibly could. And when the problem arose of, we just cut thousands of parts, and you see someone walking through a factory with a clipboard, checking off, we had spun up, we had our own internal issue. The Excel sheet got too long. And so we spun it up into a SQL database, and we could write our parameters from CATIA directly into the SQL database. So we were tracking
our status of like what we released for production, this stuff that way. So when you see someone else on that team, in this case, the sub having challenges with it, managing data we can spin up an iPhone interface. And at that time we weren't writing apps. We don't often tell that story. This was FileMaker. We created an interface for FileMaker, like just a front that was running on an iPhone that then would link back to the SQL database. So FileMaker was really just a sort of fake app front.
Like a UI.
It was a UI. But what that allowed us to do is have them capture real-time status of things based on barcodes we would send them, because that was easier for us to manage. And then we could host the model online. And to host it online, there's a whole other roundabout trickery of like, we were using Navisworks, and Autodesk had recently bought Navisworks. So there's a whole thing of going into the technical, accessing the kind of tech wizards behind the product now in charge at Autodesk, and understanding how to link that in real time to SQL. And there were challenges that we worked through. But what we were doing was hosting real-time stat, like trying to make everyone's job easier, because there's just no time for producing reports and doing things the traditional way. So we didn't set out to do it. It was all in service of like solving something that would just take too long for someone else to do or maintain. So automate, and then it was just a series of some, success in that, like it worked. So we would then automate the next thing and work with the, manufacturers and the contractors, getting really good at understanding how to read LiDAR information, scanning, so that we could, before the panels that were coming out, we could analyze where they're going to fit and coordinate a whole round of logistics on like preemptive clash detection in a way. There were just a whole series of things that we spun up solutions to quickly to make it work, or to facilitate it. Again, in collaboration. We're not manufacturing experts, we're not installers, but understanding the constraints and automating it. That's what we could do. We could automate the result of what people were describing to us. And when the dust settled from that, we realized that what we had done was set up a good process for design authorship, to rig automation of, systems in real time, tracking geometry and reporting it well. So we had this kind of end-to-end set of solutions that we had produced, or hacked together through other solutions. So as we then, once the dust, like I said, the dust settled, moving on to new projects, we realized we could spin up WebGL viewers on our own. We could build more robust SQL database, or I should say more better relational databases. So we can ingest and track and visualize the data we were producing much faster in tools that we were spinning up, and we could adjust those. So like CATIA, a phenomenal CAD CAM solution. It also does it has a lot of other features, or there's a very deep ecosystem. Some of it's more robust than things we need. So understanding how we can build our own tools that can quickly allow us to share data with others, post things online quickly. I think we were looking at what solutions we used, what worked really well, and then what were ones where we could write our own viewers or pipelines that made it faster. And we have a good roadmap. We have a template of an end-to-end digital process, and we could see the sort of gaps in the missing features. And to date, we've just been building some solutions that help our clients or certain collaborators or stakeholders access and visualize that data easier. So none of it was, we weren't trying to create commercial tools. We're not
it was out of necessity.
It was out of necessity. And then there's just ways now I think we know. I mean, it's interesting because I think that a disclaimer of this is we haven't done, Barclays was unique. It was a unique, perfect storm of constraints. We move now on to the harder parts of defining the incentive, like reward structure of that, how are contracts written that enable this way of working, and then you sort of run directly into the reality of how big our industry is, how it actually works, how messy it is, and the innovation is going to now happen on these collaborations, on these teaming arrangements that allow us as an industry, the designer, the contractor, the developer that has the appetite for this, to realize these ways of working. Again, it's not a technology issue. It is now like, that was almost, Barclays is almost a mythology at that point, which is frustrating because you want to repeat. I think we can scale this. If we were to do another stadium, we actually did it with that same client contractor group on Nassau Coliseum. We reclad the exterior, incredibly efficient process. Different subcontractors, they were very tech enabled. It allowed, it was in a way that's almost anticlimactic, which is how I think the more this progresses,
it should be.
It should be.
Yeah.
But you just, it's the industry. It's so big. It's so hard to just continue that scale and to get that really right condition of stakeholder group.
There was something you showed me. Evan, I'll strap to Evan and then I'll let you tell me where I was wrong or what I was getting wrong. But John, a few months ago, showed me a project that I think it was walkways or bridges. And one of the things that he was showing, I just want to bring this back to like proper use of technology, which, was that they could design this bridge and these walkways, and then you end up slicing it up, right, through using the technology to slice the shapes. But then being able to, to analyze this for, I'll say, constructability and cost, which is, you don't want every shape to be different if you don't have to be. So they were able to go through then and measure tolerances and say, these are close enough to be the same, these parts. Yeah. And now we're going to standardize those parts. And now we've reduced this down, what could have been an but a lot of individual parts where one would have been so close that you could have told to a kit of parts now that are cut with now assembly instructions for that. That just really stuck with me, John, when you showed that, because it is, it's, in my mind, it's doing two things. We're cutting down cost ultimately, so that this is, and then ultimately making it easier for the manufacturer, to maybe mass produce these pieces and parts that are going to end up being part of this project.
It's interesting. I mean, that project, we almost ran some of our there are other tools that we've created over the years now, little solvers, not little, or like we'll create a solver and then expand. It would also be great if this thing could check if holes were aligned and if there's a certain tolerance that needs to be hit. Like, it's basically, we had been automating QA/QC.
I was going to say, this sounds like an automated QA.
And that's how it has to work. I mean, we've been through, projects where you're producing millions of parts, fabrication, and you start off with this, 100-point checklist of going through, and no one's going to, you can spin through and you can check every element. It's just not the right, philosophically, it's not the right way to do it. You have to understand the system, understand where the problems could happen in automation, because they can, but that's unique to this software. Did it update or not? Am I running it on the right multi-threaded, machine? You have to understand that's one of the benefits of building some of the solutions yourself, is that how you did it and what's going to go wrong.
Right.
But it's been a collection. So we're in this phase now where we've built a lot of solvers for various reasons, egress analysis or kind of spatial adjacency analysis. So there's all design analysis solvers, there's fabrication, system analysis and solvers. And in those tools, we built something that looks at all the parts of something. And if something's you set the tolerance. We actually use it for a totally different application. Replace those parts with block instances of that, so we really know how many unique parts there are. And then within that, and again, that's not something people don't typically use Rhino in a really kind of advanced fabrication way. I shouldn't say ever, but designers aren't thinking of blocks and nested blocks or unique parts. I think you're designing, but you can take sort of freeform design or at least, what we've experienced, the tools we've made allow you to be creative and create design and then rationalize it and put a logic over that, which then can package really well and go into a tool like CATIA or SolidWorks to understand the sub-assembly relationships. So what's interesting is if you go on our website, you don't see a lot of infrastructure projects. You don't see some of these projects that we are, I think, increasingly uniquely positioned to help support. I think infrastructure for sure, transit, pedestrian path, bridges, tunnels, things that the tools we made would lend themselves really well to this. It's a challenge because that, again, the industry doesn't operate that way. It's not a great template for, so how is that value received? Or how is that, we are certainly adding value or have the potential to add value. But how do you set up the contractual model? Is there even an appetite to work? Because it does take a different, you want the engineers, you want the manufacturers on board in the design process, which is not, I think there's a sort of myth to that it doesn't work with competitive bidding, that there's going to be some advantage of allowing, bidders to look at it and then apply their systems. I don't think that's mutually exclusive. I think you can design with that wireframe approach, you could evaluate multiple systems on that.
So all things constrained, in your mind then, are for the same money working in this, you should get a better product.
I think there's a win-win-win scenario where it is a better product, it's faster, and it's at the margins of all, of the designer, of the manufacturer, contractor are all higher, and the project is less expensive for the owner. And I know that all sounds overconstrained, but I think the result of really efficient ways of working, nothing de-risks a project more than creating a digital twin of it. And the reason people don't do it is because I don't think they have access to the tools or understand the role of automation in allowing you to model all the components. And then it's whose responsibility is it? And, it just gets quickly buried under risk adverse and rightfully so, contractual language. I mean, the exposure is that's a real thing.
If you think about the construction side, right, which is most of the money, right, that's going into this, and if it's roughly split half materials and half labor, maybe you can talk about the project that you all did in Africa, where I know you described when you were here in September. It showed like they did like stuff got fabricated and shows up on site with a relatively low skilled labor force, right? That's able to assemble, what is this beautiful, looks complex project, but all you had to do is say, I can look at these drawings,
sort of like IKEA diagrams.
Yeah.
I'm aware of this project, and it was a long time in the making, right, John? But it actually is a really incredible story because of the extreme focus you have on using local labor and I think materials even to build those projects.
Yeah, it's fabricated in South Africa, Cape Town, South Africa. I mean, it's interesting because you always knew that it was going to be, that was part of the government mandate on this project is that it's going to be done in local labor, and there's a lot of knowledge transfer that would happen. I mean, in terms of again our approach towards, like, we will always show people how the modeling process and sort of show the steps and the work. So there's no secret sauce in.
Yeah, you're not hiding.
We're not hiding it. Yeah.
And like you talked about avoiding abstraction from the very beginning. Like, you're not interested in that because you don't want somebody to actually have to interpret what you're drawing and come up with their own way of doing it when you're trying to get that design intent realized.
That's right. And so, but that's one of those things you can size based on the material use and aluminum extrusions and bent aluminum panel. Like, you can right size something to be picked by 2 to 3 people. It can be hoisted up by a rope instead of a crane. I mean, when you work this way, you understand the weight, what what subassemblies, what parts people are handling. You start to have empathy around if someone's going to assemble this comes off a water jet and there's 100 pieces cut. Of course, they're going to be marked with what part they are, but what orientation do they go? And if you're just given a box of parts, like ship loose parts, how do you even start to sort those? So you work with the suppliers, and there's a kind of shorthand or the things you can encode into it that are human readable of, you put a chamfer on one side that always indicates that that's down. In that case, the fastening system is very simple, rivets, and the things can really only go together one way. So it's self-jigging in a sense, but it lent itself well to sub-assembly into flat pack frames, and then you would ship most of it assembled.
It's the IKEA.
It's an IKEA. We ship 3,000 IKEA rain screen. If IKEA made
pack with a diagram.
What would you call it? What kind of a cool IKEA name would you give it?
Rain screen card. I don't.
What we're really talking about is communication.
It's communication.
It's flow of information from one person to the next person, and what is the best way or the most meaningful way to be able to do that.
I mean, if you think about a typical drawing set, I mean, the amount of annotations and dimensions that are on everything, because the standards you have to dimension, and you don't dimension something twice if it's dimensioned here, you don't dimension another because you don't want. Well, also, I mean, it's also like legal thing. You did it here, and that's the source of truth. But the amount of information that is on a page, I think a lot of people kind of shut down, or it's just not accessible. Whereas
overwhelming.
We're talking about if you can understand of how the sequence at which the project is being produced and shipped and going together, the information itself can be really accessible. Like it can be so simple. There's no one part of a project that's really complex. It's an aggregate. Like you want to keep detailing really simple. Like you want them to be performative but simple, so that the complexity of the building is the aggregate is how many parts, and how accurate those tolerances are. It's just, it compounds into something very hard. But step by step, it's all, someone's going to pick something up and needs to know where that goes. And if it doesn't fit, you need to know why. So am I holding the right thing? Or is it is this sequential order of operations. And the more the pieces of those are increasingly manufactured, the likelihood that their intolerance is greater. But then you're shipping, you're reducing the part count, which is all sort of offsite manufacturing, is just reducing part count because you've got parts and they're pre-assembled for you to go. And that's happening a lot. But you've got less parts, and then understanding the sequence of those. And the more you simulate that digitally, the more well choreographed it'll be on site, and simpler the instructions are. You can, we're gonna mark where the bottom of that is, and so there's opportunities to choreograph a much more efficient.
Oh, I can't tell you how many things I've put together where I put it on that panel on upside down, and then I got to take it back apart when I figure out the next one doesn't fit. It's like, why didn't you just mark it? Right.
It's interesting that you think about this from like an empathy kind of point of view, because like you start to blur the lines between means and methods when you're doing that, right? Because you're talking about assemblies of parts and how these things go together, but you're also kind of adding in a layer of the right information at the right time, right? Like what we're guilty of, and because of the way insurance and risk and all these things work, is all the information is there up front, right? Because then it's like, well, now we're covering our ass, right? Because we've got it all on there. But you're actually talking about just showing people what they need when they need it, right? It's this just-in-time kind of mentality. Also with the understanding of what they're going through to actually produce the thing at the point in time that they need to produce it. Like this is another level of understanding, but also what you're willing to go through to get into your models so that can happen.
Yep. I think empathy is a huge, I think that, again, when we get into this, it's not a technology issue, it's a behavioral issue. And the behavior is that this industry is not set up for people to trust each other. It's
adversarial.
For a lot of reasons, it's very adversarial. And I think empathy is an absolute critical part of understanding or enabling better collaboration, because I think our experience is when it's been really successful, these are groups, things will always go wrong. Something's going to be miscut, or you're going to have the wrong piece, or there are always going to be challenges. I think leveraging technology can greatly mitigate, how many things go wrong. But when you're understanding that people are really trying to consider, it's interesting. I mean, I'll jump back. A quick anecdote in Barclays is there was, we were designing these panels, these weathered steel panels, and we didn't know how they would connect to the bigger units. This is really kind of early design. And the contractor is like, it's a long lead item. We have to order 600 tons of steel. What sheet size should we order? It's like, we had thought about that. We found, I quickly Googled a nesting software and found this incredible nesting software, Sigma Nest, and got it, downloaded a trial version and was able to lay out all the panels of our kind of trending designs, because we had that was automation. We could unroll all of our panels. And we thought we were really clever. We're like, give us, we'll do this study, and by the end of the week, we'll get back to you. And we thought we were really clever because in that nesting software, you could pick multi-sheet. It's meant for large scale production of water jet plasma cuttering companies. And we're like, if you do 3 different sheet sizes, we can get it down to, really small percentage waste. And we were so proud from a computational problem solving, we nailed it. And the foreman in the factory floor, the manager was like, that's super impressive. If I have 3 piles of sheets on my factory floor of different sizes, the people have so much going on in the factory, they will pick the wrong sheet and put it down. The likelihood that they'll put the wrong sheet on the water jet and cut and end up with more waste, there's a better chance of more waste, versus one sheet size. And I don't, just from an empathy standpoint, it's just not a calculus that we had considered. It's not, it's only 3 sheets. That's not that hard. But then when you understand what's going on the factory floor, so we basically understood where our panels were, which ones weren't being efficient, and we picked the sheet size, and then we changed our design model to max out those sheets. And so that's a design being informed by constraints.
Downstream.
Which that anecdote, one, it was more, for us, it changed, it changed a lot about how we thought about what our role was, also in terms of our expertise, which our expertise is design, composition, material application for great environments, and it's automation and visualization. It is not engineering. It's not logistics. So what we're able to do is, and just the empathy side of it is understand, listen, you've got to be a good listener.
It's a negotiation. Yeah.
And you hear what really drives the needle, what drives costs, what adds complexity to projects, what doesn't. And that's one of the issues in the industry now, is there's just so much opacity in what drives budgets, or what drives cost, and how much, just to understand from a system standpoint what the rules are, and have people explain. And one, they don't have to do this crazy laborious shop drawing everywhere. If you understand the engineering, the kind of min-max constraints, and from a supply standpoint, what materials or profiles they want to use, then we can take kind of general assembly drawings, as we call them, and automate it. So our competence is just here's a design, and here's the result of everything that you're describing. That's the result.
So John, because of those learnings, or what you do learn from, who's going to ultimately fabricate and make, do you tend to then try to identify them earlier in the process, and then ultimately have them involved earlier in the process?
I think it's always better. That's always, design assist contracts. I think design build, again, allows more of that, but we're going to inevitably move. Our industry will move to that. It's just, I think it's better to have the constraints And again, technology enables that. We can collaborate in the same environment, in the same digital environment, and we can get feedback faster.
So it sounds like
It's contract language.
sounds like in your mind that the technology has actually outpaced the ability for the market, this
I think so.
means and methods and way of working. But if you did put your technology hat on, what do you see? What are you all doing that you're experimenting with, or that might be right around the corner? There's obviously a lot of new technology around that's starting to,
Yeah.
it's got everybody's attention. So what are you all seeing or thinking about?
So, I mean, it's interesting because on our technology development, like we on the App Store, we have a project portal, like a shop portal, which is really a viewer. It was a way that originally we called it the cocktail hour app. The client could log in and, if on their own, if they were flying somewhere, with friends somewhere else, they could use it to spin the model of the project around, show, the program layout. It was a way for them to communicate the project to themselves, understand it, and communicate it to their friends. But we did that. And if you look at from a technology standpoint, it's like, we're talking about millions of fabrication parts and all this. This almost looks like a step back from heavy technology, but it's really important that we break down that barrier of access, intuitive access to the models, because we know where this goes. We know it was very easy for us in that project portal to provide real-time construction status, like the visualization, which is data, so that we can start providing data visualization in real time to a larger stakeholder group in things that they have, iPads, iPhones, mobile devices. But it's a way of trying to promote behavior around models, adding features where you can comment, you can, leave a note and respond to notes. Like, this is where we're trying to move this suite of tools. And ultimately, I think where we're positioning it is that this could be a great UI for operations. So one of the issues in the AEC industry, and certainly architects have, is we design to the best of our intuition and the kind of access to what we know have worked in the past, and our enterprise knowledge of tenets of good design that we're taught and have experienced. But we don't have access to how the buildings are performing afterwards, which it's great to hear stories when someone, and it's great to see on Instagram when your projects are being enjoyed or working the way that you had hoped they would, or in new ways. I think Barclays was super interesting to us because we designed that under the canopy was meant to be a big public forum for Brooklyn, and it was it ended up being a big area of the protests in Brooklyn, which we were super proud of. I mean, it was functioning,
As
designed.
as designed. It was, it was, and so it's good to see when your spaces are being used well and enjoyed. But we don't have any real metrics or data of like how many people are using it.
Yeah, it's kind of anecdotal at that level, right? It's just like you see the Instagram mobile backdrop, and you're like, positive success, but at the same time, you don't have real-time operating system level data of your project.
Is this space running hot? Is that something that we designed? Are certain moves that we make in design leading to higher, commercial value of retail space? And I think these kinds of things are the world is becoming more interconnected, Internet of Things, smart operating systems. And so data is increasingly important. And we produce a lot of data in the design and delivery of our projects. But the byproduct, that digital twin, and how the building is being used, there's a huge amount of data that can live on. And we think that spatializing this, spatial understanding that data over the 3D constructs that we make is going to be, that's the next frontier. It's super important. We're trying to work with clients that have larger portfolio holdings to help build tools that will, as a facility management operations, and the hope that we start getting some access to data that informs better design. So we really complete this circle.
Have you all started, John, like talking to energy management, kinds of companies that build software and applications that are trying to monitor and manage that stuff? And then over the life of the building, right? The idea that you to understand energy costs.
And again, it's a different territory than the challenges of kind of design, build, construction, all the means and methods. Architects aren't supposed to get means and methods, but the product is much better when we're all working together and understanding means and methods. This is another challenge in that we are trying to create a facility management platform. We are trying to people have them, and there are increasingly new ones that are coming out that are very robust. There are sensors in buildings, and there are ways of monitoring that. What we're trying to do is become a good spatial user interface for those. I think the future of this stuff are smaller solutions that are connected through API, that are more agnostic to large commercial platforms. And so we're excited by the emergence of companies that are looking at open source 3D, companies like Speckle, that are looking at platform agnostic 3D interfacing, accessible
through a web browser.
Well, you've got I guess at least two fronts. One is simulation. If you've got 3D data, can you use it combined with other things to simulate?
Yeah.
And then you've got as a UI or UX, like it's a natural interface for a human to see something in 3D and go, okay, I understand especially where I am or where that is, which room that's in. Mm-hmm. Yeah, I think it's a natural. It seems like it should be natural, not forced.
Yeah. If I want to hack into the bank, I mean, there's real world. It's not just like, oh, I've got to go through 3 armed guards, and there's actual what spaces are drawing the most energy. Like there's heuristic filters and views that we can now quickly query and understand. But I think if you start overlaying really big data sets and spatialize them, we're going to start seeing some emergent results of why certain spaces, that the direction they're facing, how people use them, receive them, as a result to energy management, to like financial performance. Like I think we're going to start seeing more actionable patterns of data, and the more we collect those and kind of collect data and run analysis in real time, the better. That starts to get off into another kind of.
It's kind of interesting. I was just sitting here thinking about ultimately the goal is to convey the most information as simply as possible.
Yes, that's right.
Now the question is, what form should that take? I've actually got a friend of mine who's living back here in Lexington again. I don't know if you've ever met a guy named Rob Snyder. I should.
Not that Rob Snyder, right?
No, not Snyder. Rob worked at MBBJ, and then he was at Bentley for years. But he's been developing this. I need to get him introduced to you, John. In fact, I think the last time I talked to you about, you need to talk to the guys at SHoP, because he's got this whole. He's been working on, take a 3D model, and yes, you can convey obviously a lot of information from that. But he's been working on ways to introduce section cuts as a language to understanding. It's like, yeah, you're going to move around the model, but as soon as you want to make a cut here, you really want to see that as a 2D section, because that is the best way to understand, what that is and what it's composed of and what the relationship of parts are. So he's been trying to, to bridge that. Like there is still a place for 2D information, but can you marry it in a way to the 3D model so that depending on what you're doing and what you're seeing, you can, display appropriate information. So Rob will get a kick out of that. We've talked about this podcast because he's got kind of open sourced it now, and he's got some other people around the world interested in trying to start to integrate it into some applications.
Yeah, it'd be super. I mean, I think this is the horizon now is just great, effective collaborations. I mean, again, we make models, digital models, and we are getting good at integrate, like reading live data and lighting things up. Sort of, we're saying paint by data. This is kind of the term we've been using in here a lot. But those sources of those are vast. And so collaborating, people, we know solutions are being made, like collaborating with Cisco and Siemens and Bosch and these companies that are experts in all of this. And then, analysis, to your point, structural analysis, environmental analysis, collaborations with, like, Thornton Tomasetti is an engineering firm that we work very closely with. And it's not about, the days of, we've got our proprietary things and we're going to, in a black box, do this. And I think knowing your core competencies, we're doing, ideally we'd like to work where our creative design tools are streaming or, directly into Thornton Tomasetti structural solvers. We're receiving the results of that, and that you can make decisions quickly. And we, again, along that same speckle route, like there are, obviously we work very deeply and closely with Autodesk tools and Dassault systems. So like we're not trying to like dislodge incumbents, but we like that people coming in that are creating, schema. So we're testing where these lighter weight authorship tools that are web-based or kind of can stream into more agnostic geometry containers that we can connect analysis and data visualization to. I think this world of APIs and interconnectivity, that's the next phase of all this. And it's not like shop portal. We're not expecting that you have to use our viewer, but if you're working with us, the fact that we have our own viewer, we can serve information, or you can pull information in what we think is the really intuitive way. So we'll keep building that, knowing Thornton Tomasetti has their viewers. When you're working with them, you're expecting very different things to see. So they're not, this isn't, it's not mutually exclusive. This is now all complementary exchanges of data.
You kind of couched it under digital twin, right? But this idea of this, it lives on, right? It's as built through occupancy, through normal operating, and now you're actually testing your hypotheses, right? Like the building is a prototype, you're getting feedback, which is going to inform your next designs, but also like you now have the ability to build a relationship. And I think a lot of what you're talking about with this collaboration through digital models is really interesting for relationships, because you guys are building things together, whether it's with your consultants or with your clients, but you also now have like the bat phone, or they have the bat phone to you to say, like, are you seeing what I'm seeing?
Yeah.
Like it is or it isn't what we thought. And it allows the relationship to continue beyond the service model of providing architectural services. And now it's the building operations and ongoing facilities management with the designers involved in that process. So it reinforces what you're doing next time, but it also allows you to have that, a further understanding of what they actually have to do to operate that space. Right? We talked about empathy, but then also just continuing the relationship on with those clients. I think it's really fantastic from like a business model point of view as well.
Yes, that is not lost on us. We want to create increasingly better and objectively better design. And that means, are we doing things a certain percent faster? Like there are KPIs we want to set. And are the buildings operating the way that they had been, the intent and the design? And we want that. Again, you talk about like we're able from the Lean's method standpoint, the idea that we can adjust design to meet fabrication constraints, and that is correct. You want that. But now, you step back, the idea that we are really designing data-driven design that is coming from the performance of our buildings, the way that they're being received by clients, the occupants, like that, that needs to happen. We're really excited by what, that horizon as design professionals of like really being data-driven.
If anybody listening to the podcast hasn't visited y'all's website and seen some of the projects. It's always exciting to see. And so we'll put some stuff in the show notes. And, I just want to say thanks again, John, for coming down this past Confluence event. We're always pimping the Confluence event.
No, I appreciate. Look, I mean, I'll the plug for that is, it's found it's one of these really relevant events where people are there to have discussions, like real discussions. It's not people trying to kind of sell their wares or over present their overinflate how they operate. It feels more real talk. It feels really focused around relevant topics in our industry, and we are very happy to obviously contribute where we can, but to participate in this. I mean, we look forward to continuing that relationship because it really is relevant.
Definitely appreciate it, and the magic of that event is people like yourself, coming and being willing to share, and I think it's that's what we're trying to foster is kind of an open environment. It's the intersection of where technology meets the design, the practice. Trying to get people to share these kinds of thoughts. So definitely appreciate your participation and thanks for joining us on the podcast.
Thank you.